Hello, lovely geometry students. Welcome to lesson 6.07, where we're going to work on partitioning a line. So our goal today is to find a point that partitions a line segment in a specific ratio using slope. As a review, check out the do now. Use your notes from the previous lesson. The line 2x plus 3y equals 6 is dilated by a scale factor of 2, centered at the origin. Write the equation of the dilated line. Try this out. Don't just copy. This will be on the formative and the summative, so giving you plenty of practice opportunities. And play once you're ready to review. Alrighty. So the first step of dilating a line is checking to see if the center of origin or the point is on the line. So we need to get y alone. So I'm going to rewrite this equation in standard form. 2x plus 3y equals 6. I'm going to subtract 2x on both sides. I'm going to write the term with the x first and then the constant, the number alone. And to get y alone, we're going to divide out the 3 on all terms. So if I simplify this, I get y equals negative 2/3 x plus 2. So we have to see if 0, 0 is on the line. So my x value is 0, my y value is 0. So I just substitute. Anything times 0 is 0. And 0 plus 2 is 2. So here, 0 does not equal 2. I put the equal sign and put a slash through it. So since this point is not on the line, we just multiply the y-intercept. I'll rewrite it. I just multiply the y-intercept times the scale factor, which is 2. So when I rewrite it, my final answer is y equals 2/3 x plus 4. 2 times 2 is 4. Now, we wrote our equation. Will these two lines intersect? The original equation and our new equation. What do you notice about the slope? They are the same. So no, because equations with same slope are parallel. So parallel lines never intersect. Pause if you need more time, and play once you're ready to move on. Alrighty, so we need a quick ratio review before we start this lesson. So partition a line segment. Divide a line into parts. Find the ratio of AP to PB. So this colon means ratio. You could write it in colon form or fraction form if you remember from middle school. Same thing. Now, let's see how many parts there are. 1, 2, 3, 4 parts. So AP is one of those parts, and PB is 1, 2, 3. So the ratio is 1 to 3. And just a heads up, the total number of parts, you add the two numbers, 1, 2, 3, so the total number of parts is 4. And we see there's 1, 2, 3, 4 parts total. Keep that in mind, you need that. Your turn now. Find the ratio of AP to PB in questions 1 and 2, and play once you're ready to move on. Alrighty, so I like doing the hops. The ratio of AP is 1 to PB. PB, there's 1, 2. So the ratio is 1 to 2. The total number of parts is 1, 2, 3. So check it. If you add 1 plus 2, it equals 3 total parts. Number 2, the ratio of AP is 1 again. And PB is 1, 2, 3. The total number of sections is 4. 1, 2, 3, 4. And you can see 1 plus 3 is 4. So let's apply this to the coordinates using slope to partition. So a synonym of partition is to divide into parts. The coordinates of endpoints AB are A, -6, -5, and B. Let's graph those points and label it. Label that A, and B is 4. We go left or right first, so 4 to the right, and we don't go up or down, and that's B. I'm going to connect this segment, and sometimes it's called a directed line segment on the regions. Now, point P is on AB. Determine and state the coordinates of P such that AP to PB is 2 to 3. So P is somewhere on this line, but we need to figure it out. So, step 1, find the slope. So we're going to use the rise over run form. So we're going to go, the slope is positive, so the rise is 1, 2, 3, 4, 5. Right, step 1. And the run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the rise over run is 5 to 10. Step 2, add ratios to find the total parts. So one second. Oh, so we need to partition it from 2 to 3. So we need to find the total number of parts. To do that, you add the two numbers in the ratio together. 2 plus 3 is 5 equals 5 total. And we're going to, step 3, we're going to divide the rise and the run, 10 over 5, the numerator and the denominator by 5, the total. So 5 divided by 5 is 1, 10 divided by 5 is 2. So we're going to partition the line using this new slope. So we're going to go up 1 over 2. Put a dot, up 1 over 2, up 1 over 2, up 1 over 2. And we have partitioned the line. Check it. There's 1, 2, 3, 4, 5 total sections now. And now, since we need the ratio 2 to 3, we're going to go, there's 1, 2, 2, 1, 2, 3 parts. So P needs to be right here. And that coordinate point is -2, -3. Step 4 is on the graph, and step 5 is -2 to -3. All right, and it says the use of axes below is optional. So remember, there's a coordinate grid on the back of the readings that you're going to rip out and use, and you could draw your own axes. So the last page, you could rip it off. And the last page also has a spire, which will give you an algebraic way of partitioning a line instead of graphing, but the graphing is the easiest. Let's check out example number 2. Using slope to partition. Directed line segment, so that just means segment PT, has endpoints whose coordinates are p, -2, 1. Let's graph that. Start at the origin, go left for negative up 1p. And t is +4, 7. Determine the coordinates of point J that divides a segment to the ratio of 2 to 1. So let's connect this directed line segment. And step 1. We're going to find the rise over the run. So I'm going to go, this is a positive slope. I'm going to go up. 1, 2, 3, 4, 5, 6. So the rise is 6, and the run is 1, 2, 3, 4, 5, 6. 6 over 6. Step 2. Add the ratios together to find the total number of parts. The ratio of 2 to 1. 2 plus 1 is 3. Step 3, we're going to divide the rise over run by the total number of parts, both the numerator and the denominator, so it's going to be 2 over 2. And we're going to use this new slope to partition the line. So I'm going to go up 2 over 1. Oh, up 2 over 2. Boom. Up 2 over 2. Up 2 over 2. And now you can see that we have 3 equal parts. So this was step 4, and in the graph. And step 5, we find the coordinate. So J needs to be here because the ratio of the line is 1, 2. That's where J is, to 1. So the coordinate of point J is going to be +2, +5. Pause this video if you need more time, and let's move on. So like I mentioned before, on the regions, they'll most likely just give you a question. And the last regions in January, there was no graph. So I want you to tear the last piece of paper out. It's not on this screen share, but it's on your paper. So rip out the grid. And one sec. Oh, I didn't take a screenshot. And you're using your separate doc, but I'm gonna use this. And because the paper you ripped out has no grid, so you're gonna put your own X and Y axis, okay? So you should draw the lines. The endpoints of DEF are D1 to 4. Let's graph that. And F is, I might run out of space, but all good. 2, 4, 6, 8, 10, 12, 14, 16. And go up. 2, 4, 6, 8, 10, 2, 4, 6, 8, 10, 11, 12, 14. So it should be over here. And this is F. And state the coordinates of point E. So it's in between D and F with the ratio of 2 to 3. So first, I'm going to find the slope. And since I ran out of space, I'm going to do it the algorithmic way. So step 1. I'm going to do 14 minus 4 over 16 minus 1, and I get 10 over 15. That's the slope. I'm going to find the total, adding the numbers in the ratio together, which is 5. And then I'm going to divide the rise over run by the total. 5 divided by 5, so I get 2/3. And this is my new slope. So I'm going to go up 2 over 3, up 2 over 3, up 2 over 3. My graph is slightly off because it should be on the same chart. And up 2 over 3. If I keep going, there should be 5 sections. 1, 2, 3, 4, 5, because 2 plus 3 is 5. And we just need 2 of those partition sections. So 1, 2, 2, 1, 2, 3. So the point E is going to be cha. And if that point is 7 and 2, 4, 6, 8. 7 over 8. So if there is no graph provided, you're going to have to use that grid paper multiple times and do the checkpoint and try to get to the aspire section and work with your table mates to do the algebraic way after you do the exit ticket. All right, see you next time. Bye.